Next up, the elastic properties of materials. In particular, we take a look at stress and strain concepts in this video. Most materials are elastic up to a certain point. When we say elastic, when we deform an object, and then when the deforming influence is removed, the object will return to its original size and shape. For example, consider a rubber band. You stretch the rubber band and then you release it. The rubber band will spring back to its original size and shape. Most materials are elastic up to a certain point. But as long as that point is not exceeded, the object or material is elastic. When deformed, and then released, the object will go back to its original size and shape. Stress refers to the force per unit area that is deforming the object. So we can say that the deforming influence is stress and it is force applied on a particular area. So stress is force divided by area A. Now this area A might be surface area or it might be cross-section area. As long as force is applied on that area, F over A is the stress experienced by the object. And the resulting deformation is measured in terms of what we refer to as stress. Stress refers to the deformation an object experiences due to stress. So, stress will bring about strain, and depending on the type of deformation that happened, there are different ways of measuring strain. When you compare strain and stress that is causing the strain, it was observed that stress is proportional to strain. The deforming influence is proportional to the deformation that it causes. The constant of proportionality between stress and strain is referred to as the modulus of elasticity of the material. Modulus is just equal to stress over strain, and the unit of modulus is Newton per meter squared or Pascal. Incidentally, stress is also Newton per meter squared. So, stress and modulus have the same unit, Pascal. Modulus is equal to stress over strain. Modulus, Pascal unit. Stress, unit is Pascal. To maintain the equality, that means strain is unitless. Strain must not have a unit. So, strain must be a measurement of the deformation in such a way that strain does not have a unit to maintain the equality of the units. Because modulus, unit is Pascal, stress, unit is also Pascal. As mentioned, materials are elastic only up to a certain point. If this point is exceeded, we say that the stress exceeds the yield strength or elastic limit of the material. When yield strength or elastic limit is exceeded, the deformation that the object experiences will become permanent. Whenever you stretch an object, say, get a piece of plastic, a plastic bag for example, you stretch the plastic bag, eventually, if you continue stretching it, eventually you reach a point wherein you see discoloration in the plastic. And when you release the plastic, that discoloration, that stretching mark, will not disappear. That's because the elastic limit has already been exceeded. If you continue stretching the piece of plastic, eventually the plastic will rip apart. The ultimate strength or breaking strength of the material has been exceeded. Depending on how the force is applied, an object will experience different kinds of stress. And due to the different kinds of stress, you have different types of strain. It's because stress will cause the strain experienced by the object. The influence will cause the deformation. Therefore, the type of influence will determine the type of deformation that will happen. As such, we have different types of modulus of elasticity. We have Young's modulus of elasticity. When an object is stretched or compressed, its length is affected and the object is said to experience tensile stress. So we're talking about length deformation. You have an object, cross-section area A, initial length L0. If you stretch the object, you apply force F on each end of the object, applying force F such that F is perpendicular to the cross-section area. The object will stretch. From initial length, it will have final length L. And of course, change in length is just final length divided by initial length. So you have length deformation, force applied perpendicular to the cross-section area, that's tensile stress. For tensile stress, the strain is measured in terms of delta L and L0. And we have Young's modulus Y. Y, the constant of proportionality between stress and strain, modulus Y is equal to stress divided by strain. Stress is F over A, definition of stress. But in this case, F is perpendicular to A and A is cross-section area. And the strain is measured in terms of delta L and L0. Delta L divided by L0. Meter divided by meter. Strain does not have a unit. So Young's modulus is equal to stress over strain is equal to F over A divided by delta L over L0. On the other hand, if instead of perpendicular to the cross-section area, you apply the force parallel to the cross-section area as shown in this figure, you have shear modulus, and the resulting stress is shearing stress. You have an object, cross-section area A, initial L0. You apply force F parallel to the cross-section area A. And then on the other side, you apply force F in the opposite direction parallel to, again, still parallel to cross-section area A. The object will experience a deformation that can be measured in terms of angle. We say the object experiences angular deformation. For angle theta measured in radians, for angle theta to be equal to very small value, for very small angle theta, the shear modulus G is just equal to stress over strain, F over A, stress, wherein F is parallel to area A, cross-section area A. And strain is measured in terms of angle theta. Again, theta is in radians and it must be very small. So, G is equal to F over A divided by theta. For very small theta, tangent theta is just equal to opposite over adjacent. So, delta X divided by L naught. For very small theta, tangent theta is just equal, almost equal to theta. So, theta is just equal to opposite over adjacent, delta X over L naught. For Young's modulus and shear modulus, A is cross-section area. The force is applied on cross-section area. For Young's modulus, force is perpendicular to cross-section area. For shear modulus, force is parallel to cross-section area. If the area is surface area, meaning the force F is applied on all sides of the object, the object is experiencing fluid pressure. When the stress is due to fluid pressure, the whole object will either expand or compress, contract, depending on the pressure P. Since the volume will change, the whole object will expand or compress or contract. The volume will change. You have bulk modulus B. B is equal to stress over strain. Stress is the pressure, the fluid pressure affecting the object. Force applied on the whole surface area of the object, resulting in volume change, initial volume, final volume. So that's stress, pressure, P. Strain is measured in terms of volume. Change in volume divided by initial volume. So, bulk modulus is equal to pressure over delta V divided by V naught. Unit of pressure is also Pascal. And that's it for now. That's it for this session. In the next video, we'll take a look at the concept of Hooke's law. So thank you for watching.